Example 3. Find the exact value of the 6 trigonometric functions of the angle theta in the given triangle. All right, same kind of problem as examples 1 and 2, different triangle. All right, so first thing to notice, we have a right triangle. Here's our little square notating that this is a right triangle. Okay, if we go straight across from the right angle, this is going to be our hypotenuse. Okay, notice we don't know the length of that side. Okay, so we need to calculate what the length of C is. Okay, we know the other two sides. Okay, here's our angle theta that we're interested in. Okay, we go straight across. Okay, we know the opposite side has length 3, and then the remaining side has to be the adjacent side, so that also has a length of 3. Okay, so we're going to have to go to the Pythagorean theorem and use that to calculate the length of the hypotenuse. Okay, so we've got a squared plus b squared is equal to c squared. Let's plug in what we know. We're solving for c. C is reserved for the hypotenuse. Okay, again, it doesn't matter, how you label the opposite and the adjacent. I'll just label the opposite as a and the adjacent as b. Okay, but it does not matter. All right, so a squared is going to be the opposite side squared, so that's going to be 3 squared plus b is the adjacent side squared, so that's another 3 squared. That's going to equal c squared. All right, and so if we simplify this, we're going to get 9 plus 9 is equal to c squared. So that tells us that c squared is equal to 18. Okay, and so we want c, not c squared. So to undo the square, we're going to have to take the square root of both sides. Okay, so we get that c is the square root of 18. Okay, now this is a square root that actually can be simplified. So let's go ahead and do that before continuing. Okay, so I'm going to go and make my factor tree for 18. 18 breaks down into 9 and 2. It breaks down into 9 breaks down into 3 and 3. Okay, so if I'm doing this, and that's as far as I can go because 2 doesn't break down any further and neither do the 2 3s. So the square root of 18 is equal to, we're going to grab our numbers at the bottom of the branches, okay, put them in order and multiply them together. We're going to have 2 times 3 times 3, okay, underneath the square root. You can check yourself. 2 times 3 is 6, times 3 is 18. So both the left side of the equation and the right side, they're both square root of 18. Okay, so once we have it written like this, then you're going to go looking for pairs. Under the radical, we've got a pair of 3s, so one of them comes out, okay, and it leaves just a single 2 underneath the square root, okay. So the square root of 18 is the same thing as 3 square root of 2, okay. That's going to be the c value here, okay. All right, you should always simplify your square roots if you can. All right, so now we've got the hypotenuse. We know the length of all 3 sides. We can start forming the trig ratios. Okay, start with sine. Sine is opposite over hypotenuse. Okay, so go to your triangle. Okay, and let's go ahead and grab that. The opposite side is going to be 3. Okay, and then divide that by the length of the hypotenuse, which is 3 square root of 3. Okay. This can actually simplify here. Yes, you have a square root in the denominator, so you are going to have to rationalize here, but you can actually simplify before you do that. We have a 3 in the top and 1 in the bottom, so they cancel, and this leaves us with 1 over the square root of 2, because the square root of 2 is in the bottom. Okay, so 1 is left in the top. All right. Now you've got to rationalize this guy. Okay, so we need to get the square root of the 2 out of the bottom. So we're going to multiply the top and the bottom by the square root of 2. Okay, this is going to give us, if you go across the top and across the bottom, this is going to be the square root of 2 over 2. That's your answer. Okay, so there's the sine. Okay, all right, cosine. Cosine of theta is the adjacent over the hypotenuse. All right, so let's write this down. If we go to the adjacent side, it has length 3, and then we have to divide by the hypotenuse. The hypotenuse has length 3 square root of 2. Okay, it's actually the same as the sine. Okay, the sine and the cosine here are equal. Okay, so I'm not going to repeat the work for simplifying this, but if you went through the same steps that you did for sine of theta, this is going to simplify to be a cosine of square root of 2 over 2. Okay, sine and cosine are equal here. All right, moving on to tangent. Okay, tangent is opposite over adjacent. Okay, so let's go grab the opposite side. The opposite side is 3. The length of the adjacent side is also 3. So you get a tangent of 1 here. Okay, nice and easy number there. Okay, all right, let's go to the cosecant. Cosecant is 1 over sine of theta. Okay, so go to 1 over sine of theta here. Okay, when you have 1 over something, you're going to flip it. Okay, so if we go to the sine, our final answer was the square root of 2 over 2. We know if we flip this, it's going to send the square root of 2 back to the denominator, and we're going to have to rationalize. You can go back to initial setup if you want. Initial setup might be a little complicated, so if you want to go back to initial setup and try to do it from there, that's fine. Or you can go ahead and just flip the final answer and rationalize the denominator. Okay, so if we flip the sign, we're going to get 2 over the square root of 2. Okay, we've got to rationalize the denominator, so multiply both by the square root of 2 over the square root of 2. Okay, multiply across the top and the bottom. So if we multiply across the top, we're going to get 2 square root of 2 over 2, and then there's a 2 in the top and there's a 2 in the bottom. Okay, remember, you cannot divide into what's under the square root. Okay, but there's a 2 on the outside and then 1 in the denominator. Those cancel, and so the cosecant of theta is the square root of 2. Okay, you could have gotten this from initial setup from flipping right here. Okay, if you had flipped right there, once we canceled the 3's and got 1 over the square root of 2, we could have flipped that. That's the part before rationalizing. Okay, you could have also gotten it from the picture. We know cosecant is 1 over the sine of theta, and sine of theta is the opposite over hypotenuse, so that means that cosecant is the hypotenuse over the opposite. Okay, so if we did that, if we went back up here and we wrote down the hypotenuse is 3 square root of 2 over the opposite is 3. Okay, so you could have done this, and then the 3's would have canceled out. Okay, and it would have still left you with square root of 2. Okay, so that is the answer for cosecant of theta. All right, moving on to secant. Okay, secant is 1 over the cosine of theta. Okay, so we can go to the cosine of theta and flip it. Okay, so again, here's your final answer for cosine. So if we flip this guy, it's going to send a square root of 2 to the denominator. So we're going to have to rationalize. So let's do that. Okay, so multiply by the square root of 2 over the square root of 2. This is going to give us 2 square root of 2 over 2. Okay, again, 2 out front cancels with 2 at the bottom. Okay, you're going to get the square root of 2. Okay, makes sense. Sine and cosine are the same, which means cosecant and secant should be the same. Okay, makes sense. Okay, you could have also treated this one as, since secant is 1 over cosine of theta, and cosine of theta is adjacent over hypotenuse, the secant is the same thing as the hypotenuse over the adjacent. Okay, so you could have gone up to your triangle here, and you could have said, well, actually, let me put this in a different color so you can watch. It's the same kind of thing that we just did for the cosecant. Okay, we know this is hypotenuse over adjacent. If we had read this off the triangle, we know the hypotenuse is 3 times the square root of 2 over the adjacent. The length of the adjacent side is 3. Okay, and then same thing that happened with cosecant. The 3's cancel, leaving you with the square root of 2. Okay, all right. Final one here, okay, final ratio is the cotangent of theta. Okay, we know that's 1 over the tangent of theta. So all we need to do is go to the tangent and flip it. Okay, 1 is the value of the tangent here. So remember, this is 1 over 1. So if you flip that fraction, you're still going to get 1 over 1 or 1. Okay, so the cotangent is also going to be 1. Okay, cotangent is 1 over tangent. Tangent is opposite over adjacent. So the cotangent is the same thing as flipping the tangent. It's the same thing as the adjacent over the opposite. Okay, so we could have gone back to our picture. We know the adjacent side is 3 units, and we know the opposite side is also 3 units. So if you had done the cotangent this way, you would have also gotten 1. Okay, so here are your 6 trig functions for this particular triangle.